if we draw a card from a deck and replace it, okay, and then we draw a second card, those are independent situations because it was the same exact situation 2 times in a row. If I did not replace it, then that would become dependent because the variables change, the probability changes when that queen is taken out and it's not replaced, okay? But since it was replaced, we call that independent. So since we are not replacing it in this lottery situation, which hopefully you figured out by now that the lottery is not in your favor, but if you win it, good for you. Feel free to share. This is a dependent situation because it was not replaced. Okay, and the last one here, flipping a coin. Keep flipping, keep flipping, keep flipping. If you get a heads, it doesn't like go away once you use it. You can still get a heads the next time. So we would say that's an independent situation. It does not depend on the numbers or the situations that happened before it. Okay. So as we look at a situation here, if things are independent, this probability of A times B, it means you can multiply them together. So if a coin is flipped and a dice is rolled, those are completely irrelevant. If I get a heads, that does not affect whether or not I roll a 6 on the die. So if I'm looking at what the probability of getting a heads on the coin is and a 4 on the die. So again, that and situation is that overlap in the center here. And since these are independent situations, I have a 1/2 chance of getting a heads and a 1/6 chance of getting a 4 on the die, giving me a 1 out of 12 chance total. Okay. If we're looking at a card trick here, if the card is drawn from a deck and then replaced and a second card is drawn, I could have gotten a queen that first time. There's 4 queens out of 52 total cards. And then there is still 52 cards in the second round because it was replaced. If it wasn't replaced, I would have to have 51 down there. Okay, but then it wouldn't even be independent anymore. So 52 is again, and there's 4 separate aces. So that is where I'm going to get that. If I reduce both of those become 1 out of 13. And 1 out of 13 times 1 out of 13 is 1 over 169. So if we've also got a situation where we've got that the probability of rain on any given day in March is 1 out of 5, 20% chance. What is the probability that it rains 3 straight days? So it's saying that the 3 days are independent here for this to work. So the first day you've got a 20% chance, 1 out of 5. The second day you've got a 20% chance, 1 out of 5. And the third day you have a 20% chance, 1 out of 5, giving you 1 out of 125 chance that it would rain 3 straight days in March. So pretty low percentage that it would rain for 3 days straight in Daytona. So if we look at these 3 random days here, March 10th, 11th, and 12th, you've got a 1 out of 5 chance that it would rain on the 10th, not March 12th, March 11th. So that's that complement situation. So you got a 4 out of 5 chance that it will not rain on the 11th. And then you've got a 1 out of 5 chance that it will rain on the 12th, giving you 4 out of 125 as your answer for that one.